And finally, AC is equal to FH. Side, side, side tells us those two triangles are congruent. So we can say triangle BCA is congruent to triangle FGH. Did I name that correctly?
No. Yeah.
Hey guys. Yeah, Sangha.
No.
No, what did I do wrong?
You have to put G first.
So I have to put G first. Why do I have to put G first?
Because B and G has same angle.
Yeah, B and G have the same angle.
Yeah. So you have to put G first and then H. That means C and H is same.
Yep.
And then F.
And then
F is same.
you know what's a good way to check this on a triangle like this? Is follow the order. This says B to C. So when I go down B to C, if I would have already marked this up, I would have had 2 marks here. I'm looking for that same path over here, which is G to H. It goes across both of those marks as well. Then I went from C to A. C to A goes across the 3 marks. I should go from H to F, like Songha did. H to F goes across the 3 marks. And finally, if I go A back to B, we go up 1 mark. This goes up 1 mark as well. So if you're thinking proof-wise, this would be triangle BCA is congruent to triangle GHF by side, side, side. Our next one's another example. We have 3 sides, and they're congruent on the 3 triangles because we have a 3, a 3, a 5, a 5, a 4, and a 4. Can someone name this first triangle? That's one you should raise your hand on because you can't get it wrong. Well, you can. Krupa. You're saying triangle EPO. Can someone give me the congruent triangle then? What's my congruent triangle then?
Triangle
YTR. And that would be by side, side, side. Let me just double check your work. I don't distrust you, but we don't know. E to P goes down 5. Y to T also goes down 5. P to O brings me across 4. T to R brings me across 4. This goes back up to 3. This goes back up to 3. Perfect naming. Remember, naming is really powerful with congruent triangles. All right, some terms. We're going to use terms called opposite and included. Opposite is what it sounds like. It is completely across from what we're talking about. So this first one says AB is opposite angle C. So whenever I see opposite an angle, what you should think is put an arrow, and that is your opposite. So it's the one all the way across. Then the other word is included. Included just means between, kind of between 2 things. So that says that AB, I'm going to go down to this included down here. Angle A is included between AB and AC. Actually, maybe this one's probably a better one to do. So it says AB is included between angle A and angle B. So included just means it's just smack dab in between. That is included. So 2 big words, opposite and included. Opposite, go clear across. Included just means between those 2 things. Real quick, I see some people with pink sheets out. I see some people that don't. Are you allowed to write on your pink sheets?
Yes.
Yeah. Would it be probably a good idea?
No.
You need to get yours? Oh, go ahead. Yeah. The next postulate we're going to look at is angle, or side, angle, side. Ooh. This should actually say side, angle, side. Does yours say side, angle, side? Or does yours say angle, side, angle? Oh, okay. This one should say side, angle, side up here. All right, side, angle, side. Side angle side means that you're given two sides being congruent on two different triangles. And then that angle included, that means the angle between those two sides is also congruent between those two triangles. So if two sides and their included angle of one triangle are congruent to two sides and the included angle of another triangle, then those triangles are congruent. So you should be able to say this in order. You should be able to say side, angle, side in that order. If you ever have to go side, angle, and then go all the way around back here, that's no longer side, angle, side. It has to be the angle directly between those two sides that are congruent. So once again, if this would have been h is congruent, it wouldn't work because it's not included between those two sides. This angle is smack dab between GH and HF. So let's go ahead and state our congruency statement. Let me name this one. I'm going to name this one triangle CAB. Who wants to help me write that congruency on the other one, knowing that I named it CAB? EJ?
Triangle HFG.
HFG. Let's double check. C to A went across the 2 marks. H to F went across the 2 marks. A to B goes up here. F to G goes up there. Then it just finishes off. That is correct. And remember, if I'm thinking proof-wise, I'm saying that's by side, angle, side. Our next one also works. I have 2 sides, and the included angle are the same as 2 sides and the included angle of a completely different triangle. So that means, once again, that would mean that both triangles are congruent, and it means that all the parts are congruent. So once I say that these two things are congruent, that means L is congruent to Y. That means L to M is congruent to Y to O. And that was by CPCTC. Once I prove that 2 triangles are congruent, everything within that triangle is also congruent by that CPCTC. All right, let's name this. I'm going to pick angle ELM. I'll pick elm because that's like a word, right? All right, who can name that congruent triangle, knowing that I named it elm? Labib, you want to take a shot?
DYO.
DY.
Or triangle DYO.
Yeah. All right, so let's check it. So E to L goes to 9. D to Y goes across 9. L to M goes across this long side. Y to O goes across the long side. And finally, M to E goes across 3. O to D brings us back. Perfect. Those are congruent by side, angle, side. My advice is just write the 3 letters. Even when you're doing a theorem, just write side, angle, side, 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 or angle, side, angle. That way you're not taking a whole bunch of time writing all the words out. All right, then we have angle, side, angle. Kind of like side, angle, side, where you have something included. This says if two angles and the included side, so that is the side between the 2 angles. So both of these include included. Side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are in fact congruent. So once again, what you're looking out for are 2 angles being congruent, and then make sure that side that's between them is also congruent. So if I would have had GH and BC in that place, that wouldn't work because that wouldn't be included. It has to be between those 2 angles. So once again, you are looking for that included, that one that's right between the 2. So based upon this fact, we would have triangle BCA is congruent to what triangle? If I say BCA, what triangle is that? Davian? GHF. Let's check that out. So we go B to C. B to C goes down to this angle. G to H goes down the angle. Perfect. Then we have C to A. C to A goes across this one. H to F goes across there. And A to B and F to G. Now, it might seem easy naming them now, but can you picture where the triangles aren't looking the same? Like I have one way over here and one over here. You have to really take your time in those cases. It seems pretty ridiculous that I'm actually doing this check every single time because you're like, well, they're drawn the same exact order. But when you get to your homework and when you get to tests and stuff, there are going to be times where you have to go through this step-by-step check. All right, so that's triangle BCA is congruent to GHF. Once again, if they're congruent, by CPCTC, everything's congruent. So that means B is congruent to G. That means A to B is the same length as F to G. And finally, B to C is congruent to G to H. And this was by my angle, side, angle. All right, the last one. We have two angles congruent to two angles over here. And both of our sides are included. That means it's between those two angles. So these must also be congruent. So we're going to do triangle. I'm going to do N-O-M, nom. Who can give me that congruent statement? Someone that hasn't given me a congruent statement yet. Thank you. Yeah.
Triangle EYK.
Triangle EYK. So I went from N to O, N to O. You went from E to Y, so you went across this long thing. Then I went to O to M. O to M went across the 4. Y to K, does Y to K to go across the 4? No, what should it be?
EKY.
EKY, perfect. There we go. It should be EKY. So do that check after you name it. Just double check to make sure everything works out after you name it. Sangha.
Isn't it?
Could be.
O-N can be K-E-Y.
Ooh, let's double check. So right now we have EKY, right? Is that what you wanted? You want to change that?
Yeah.
All right.
Y-E-K.
Oh, that's much better. Y-E-K. Song, are you okay with that one then?
Yes, I think so.
You think so? Should we double check?
I think that's good.
N to O. N to O goes across the long one. Y to E goes across the long one. O to M goes up 4. E to K goes up to 4. Yep, we're okay. We are okay. And that would be by angle, side, angle. All right, just that little note on the top page. All I'm saying is make sure you do this stuff 3 consecutive. All right, you can't have side, side, angle. Has to be the included between the two. Make sure they stay in order. If you have to change the orders of the letters, it doesn't work. You can't use that one. It has to be specifically angle, side, angle, S, S, S. There's no really way to mix that up. It's either 3 sides are congruent or they're not. Side, angle, side, you can't change the order of those either. All right, that was my note there. All right, A, B, C, D, E, and F. We're supposed to, can the two triangles be proved congruent? If so, what postulate can be used? So your whole goal is to come up with what's similar between the two. So in this case, we have an angle, we have another angle, and we have a side that's between those two. So that is angle, side, angle, angle, side, angle. So yes, this one can be proved. And that's by angle, side, angle. All right, a nice trick that's going to show up over and over on our proofs. See how it looks like we have 2 sides? Sangha.
There's one side that's sharing.
They're one side that's sharing. That's what we talked about yesterday. If they share a side, it has to be congruent. So you can go ahead and put 3 tick marks on that line that's in between just so you can physically see. All right, 1, 2, 3 sides. If you ever have 3 sides that are congruent, then you can say, yep, that works. And that would be by, side, side, side. You want to take a shot at C? But they only gave me two sides. Oh, we have vertical angles. We have vertical angles, so we might have to do that work, right? We have two vertical angles right there. If you have vertical angles, they are congruent. Now we have side angle side on this triangle, and we have side angle side on that triangle. So we're going to say yes by side angle side. Krupa.
So we would have to draw that in on the test or something?
I would. If you would just write side angle side, you'd probably be okay. Just make sure you have it right. But the more you draw, the more points I can give you if you get it wrong. And I would grow accustomed to just drawing this, because the more stuff you draw with proofs, the easier they are to see what's going on. All right, so that is yes by side angle side. All right, the next one. Who wants to take a shot at that one? What'd you get?
They're not congruent.
They're not, but I have two sides and an angle.
It's not in between the two sides.
But I have two sides and an angle, though.
It has to be consecutive.
Oh, it has to be consecutive. It has to be included, right?
Yeah.
So right now, if you look at this, I have side, side, angle. In that order. Side, side, angle. Do we have a side, side, angle postulate? Nope. So you can't use that, so you're just going to put nope. There's no way to prove they are congruent. They might be congruent. There's just no way to prove it yet. Labib.
But the hash marks say that they are congruent.
Well, they say they have two congruent sides and one angle. But in order to prove it, you have to either have angle, side, 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 or side, angle, side. That's the only way to prove that the triangles are congruent. I agree that this side is congruent to that side. I agree that this side is congruent to that side, and this angle is congruent to that angle. But all the parts might not be congruent. All right? The only way we can prove it is those three ways. So right now, we could have, this could be 100, and this could be 101. All right? Nothing's holding them in place because we don't have a postulate that says, yes, for sure, they're congruent. So it has to be one of those. All right, our next one. We have side, angle, side, so we can prove they're congruent, right? Krupa?
The other one's not side angle side.
I have to check both of them?
Yeah.
Oh, because this would be what? Side, side, angle. So this one would be side, side, angle. You can't use that, so once again, this would be a big no. You cannot prove that they are congruent. They might be congruent, but we can't prove the triangles are actually congruent. All right, last one. Last one. Davian.
I think side angle side.
You think side, angle, side? Well, let's give it a shot.
They're saying on, so it means that's congruent.
So we have the same side, right? So they're congruent. But what about this order? Side. Is this angle between the two sides? No, it's got to be between that. So are we going to be able to prove that on this one? No, because we have side, side, angle. That angle has to, if that angle is right here, then we'd be good. In fact, it is here, right? This is side, angle, side, so this one works. But this top one is side, side, angle. So this top one is side, side, angle. The bottom one is side, angle, side, but it has to be both of them. So that's the one that makes us say nope. Yeah, Emma.
Could they be side angle side though? Because it goes. Oh, never mind.
No. Labib. Yeah. You're going to miss proofs, though.
Is it any different than how we
Yeah.
it is?
Yeah. All right. Let's step up our game and do some proofs. These first two won't be that bad. Remember, when you're dealing with triangles, you're thinking side, 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 angle, side, or angle, side, angle. That's all you're thinking when you're doing these proofs. So let's look at our given information before I start anything. It says TG is congruent to NA. So when I'm doing these proofs, I'm always going to mark up my drawings. So we have TG is congruent to NA. It says that TI is congruent to NI. So let's put 2 tick marks on TI and NI. And then we have GI is congruent to AI. All right, I have everything marked up, so let's go ahead and write our givens right here so at least I get that point. So we were given that TG is congruent to NA. We were given that TI is congruent to NI. And finally, we were given that GI is congruent to AI. And all of that was given. Now, I want to show that the 2 triangles are congruent. It says triangle GIT. GIT is congruent to some angle, some triangle. Based upon our drawing, what triangle are we trying to show are congruent? Remember, we have to name it correctly. So I'm going to write down below, well, GIT is congruent to triangle. Does someone take a shot at what triangle I'm even trying to prove is congruent? Emma. AIN. Let's check it out. G to I goes across 3. A to I goes across 3. I to T goes across 2. I to N goes across 2 of them. And finally, T to G and N to A. Perfect. So we have our congruent statement. All right, we're trying to prove that 2 triangles are congruent. So we're either going to use side, 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 angle, side, or angle, side, angle. In fact, this one doesn't take many more steps. Because which one can I use right now? John, were you going to give an answer? Or you want to take a shot at it?
Angle, side, angle.
Angle, side, angle. Well, we don't know 2 angles. There's going to be the problem with that one. We could get 1 angle if we wanted to, right? Because these would be vertical angles, so we could get 1 angle. How many sides do we know, I guess? How many sides do we know are congruent? What was that?
3.
3. Do we have a postulate that says that if you know 3 sides, then the 2 triangles are congruent?
Same side.
Not quite same side. These are the 3 we're looking at.
Oh. Side, side, side.
Side, side, side. We can use side, side, side to say we're done because we know that 3 sides on this triangle are congruent to 3 sides of this triangle. So in fact, our proof is done. Yeah.
So if you want to do like side angle side, you first have to say like the vertical angle theorem.
Mm-hmm.
Okay.
But you could, right? So you could go one other step. So I'm going to finish this one. We'll talk about another step you could have done. So my second step is we are done. They gave us 3 sides right off the bat. And we have GIT is congruent to AIN. AIN. And that's going to be, you're just going to put, and you don't have to put postulate, you just can put side, side, side. They gave you 3 sides are congruent. If 3 sides of one triangle are congruent to 3 sides of the other, we just use side, 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 and they say those 2 things are congruent. Yeah. Oh, I don't know why I put 3 down. I can't count, I guess. There we go, 2. Thank you. But there is another way to prove this one. You could have said by vertical angles, this angle is congruent to that one. So you could have had a second step saying you had vertical angles, and then a third step saying side, angle, side, which is a good thought down the road because we will have to do stuff like that. All right, let's do another one. So this one says OS is congruent to TS. So I'm going to go ahead and write that. OS is congruent to TS. It also tells me that angle OSA is congruent to angle TSA. All right, so let's go ahead and put this as our givens. OS is congruent to TS, and angle OSA is, I'm going to put that down a level, is congruent to angle TSA, and all of that is just given to me. All right, they didn't give me 3 sides this time. Last time was nice because they gave me 3 sides, and I could say side, side, side. Anytime you have 3 sides being congruent to another one, you know it's side, side, side. They did give me an angle. So what I'm thinking about is I'm thinking about my 3 possibles. My 3 possibles are angle, side, 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 and side, angle, side. Well, they gave me one angle. They gave me one angle, so I know I'm either going to use angle, side, angle, or I'm going to use side, angle, side at the end of the day. Well, either I need to find one more angle being congruent, or I need to find one more side being congruent. Can someone tell me what to do next? Yeah. The 2 triangles share a side. So look at AS. AS is the exact same length in both of them. So in my drawing, I would probably draw a double dashed line there. That way I have side, angle, side, and side, angle, side. But you're not allowed to just draw something on the triangle. You have to say why you're allowed to do that. So this is going to be a key whenever you see a shared side like that. In your proof, you're going to say this is true. So what you're going to say is SA is congruent to SA, because they're the same side, and the property you're going to use is the reflexive. Your reflexive property says A equals A, or B equals B. It's kind of like a reflection. Reflexes is like your reflection. You are the same person that's in that mirror. This is the same length because it's the same item. It's a mirror image of each other. Reflexive. You have to use this step. This is probably one of the biggest missteps in proofs, where people just look at this and draw their double line and say, well, I'm done. You can't just draw on this picture. You have to have something that allows you to draw that picture, and that is our reflexive property. And maybe I should call that 2 again. I don't know why I keep going to 3. Our step 3, I can go ahead and say triangle SAT is congruent to triangle. Someone name this for me? Yeah. SAO. Let's check it. So S to A goes across there. S to A goes across here. A to T goes across this long one. A to O goes across the long one. That comes down. That comes down. Yeah, good. Perfect. Why can I say that, though? Which one of my postulates let me say that? I'm done. I am 100% done. Alex?
Side, angle, side, postulate.
Side, angle, side. Perfect. You can either put side, angle, side, or you can put the postulate Krupa.
So, only thing reflexive lets you do is draw that angle line.
Say that again. I'm sorry.
The only thing reflexive lets you do is draw that angle.
Not the angle, the side.
Oh, okay.
Because it's the side. If you're ever saying that side is the same thing as this, because you're basically saying SA is the same thing as SA. You have to put down the reflexive property.
Because they're both shared.
Yep. There are times where it's an angle. Sometimes they share an angle, and then you'll say that angle A equals angle A because of the reflexive property. It's just whatever they share.
So
You have to. You have to. Like I said, this is the most missed because it looks like, it's like, well, obviously, Mr. Pavian, they're the same line, but you still have to put that in the proof, saying that you recognized that side. And now we have side, angle, side, and we're good. So that's how all these proofs are going to set up in your homework. You just think about side, 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 and angle, side, angle, and see which ones you can actually make happen. All right, that being said, we're done with today's lesson. Let's go over homework questions for today. Who has questions from last night's homework? Emma.
You're stating for number C, like then the point O is the midpoint of XK. Couldn't it also be the midpoint of TR?
I'm sorry, number 10?
Oh yeah, sorry.
Okay, 10C. All right, let me take a picture of it. Then we can be all on the same page. All right, you were looking at C, you said?
Yeah.
Okay.
Couldn't it also be the midpoint of TR?
It could be, but we're going off of this because it's blanketed in the same statement. So stick with what was said right above it, unless it was a new number. That's why I didn't put a new number on there. But you are 100% right that that would be true. But I was looking for this one because it was based upon this fact. All right. Krupa?
If 2 points are oh wait, it's not a whole question. Sorry.
Are you sure?
Yeah, it's not a whole.
Do you just want to ask a question?
Yeah.
You can just ask a question.
If 2-point sides make a point and they're like congruent,
Mm-hmm.
does the angle? Can you say that the angles are congruent too?
If 2 points, can you draw it for me?
So if there's like one of those
Mm-hmm.
and then another one of those, can we say that these two are congruent?
Can we say that those two are congruent? Do we have a postulate or theorem that says that?
No.
Not yet. So we can't right now. No. I get what you're trying to say, because you're trying to recognize that they're isosceles triangles. They'd have all the same angles. But right now, we don't have that. Labib.
11C.
I'll-
It's not alternate interior angle.
I don't know. Let's look at it. 11C, you said?
Yeah.
All right. I see what you're saying. So it specifically asks angle 1 and angle 3.
Yeah.
And I put CPCTC. This is the one you're looking for alternate interior angles?
Yeah.
Okay. Why you can't is because, is there anything stated above saying you have parallel lines?
Yeah.
Above here? I'm not saying down here. I'm just saying, so you are at this step here. You are at step 3.
Oh.
You are at step 3. And I'm trying to fill in these blanks. Is there anything above it that says you have parallel lines? B?
Is it?
It says they're congruent.
Oh, yeah.
It just says they're congruent. So you can't use alternate interior angles because the only time you can use those is if they're already parallel lines. But all we know is that we have 2 congruent triangles. And if we have 2 congruent triangles, then we can say these angles are the same because CPCTC. If I would have stated in the beginning, saying, this line is parallel to this line, and this line is parallel to that line, you could have picked either one of them.
Alright.
But the only fact is I gave you was that the 2 triangles were congruent, so you can't use alternate interior angles until you prove that they're parallel. Okay? And that is, in fact, your next step, right?
Yeah.
Your next step was to prove they're parallel by alternate interiors converse. Is that clear?
Yeah.
Good. Other questions? Labib? Yeah, Emma.
Okay, so if a line, this is just in general.
Okay.
Would you treat parallel, like the parallel symbol, as a congruent, or no?
No, I wouldn't.
Okay, so
Parallel just means parallel.
so it doesn't mean that they're okay. Got
Yes, you should have the 2 tick marks. You will have, so Emma, if I had on here, that is parallel to that, that's all it means is parallel.
Yeah.
Those marks won't mean congruent. What you'd see if it was congruent is, see the parallel lines up there, Emma?
Yeah.
I would also have tick marks on there.
Yeah.
I'd have double marks. Other questions? All right, guys, we have about 7 minutes. I'm going to walk around. The rest of the time is yours to work on the homework. I'm going to walk around and I'm going to check your homeworks to make sure they are completed and corrected.